This LOS is define forward rates and calculate spot rates from forward rates from spot rates, and the price of a bond using forward rates. The maturity structure of interest rates. When the spot curve is upward sloping, the forward curve will lie above the spot curve. Conversely, when the spot curve is downward sloping, the forward curve will lie below the spot curve. This relationship is a reflection of the basic mathematical truth that when the average is rising or falling, the marginal data point must be above or below the average. In this case, the spot curve represents an average of a whole time period, and the forward rates represent the marginal changes between future time periods. Okay? So n period rates at some date in the future. So we've got some nomenclature here. 0y, 1y is the 1 year spot rate because it's at time 0, it's the 1 year spot rate. 1y, 1y is the 1 year rate 1 year from now. 2y, 1y is the 1 year rate 2 years from now. 1y, 2y is the 2 year rate 1 year from now. And 2y, 3y is the 3 year rate 2 years from now. Okay? Sn is the n year spot rate, also Zn, and all are expressed as annualized rates. That's an important point. All are expressed as annualized rates. The maturity structure of interest rates. So suppose the current forward curve for 1 year rates is the following. So we have the time period 0y, 1y, which is the 1 year spot rate, which is also the 1 year forward rate because it's only for 1 year starting from time 0. Then we've got the 1y, 1y, which is the 1 year forward rate 1 year from now. 2y, 1y, which is the 1 year rate 2 years from now. And 3y, 1y, which is the 1 year rate 3 years from now. So we've got the forward rates 0y, 1y, 1.88%, 1y, 1y, 2.77%, 2y, 1y, 3.54%, and 3y, 1y, the 1 year rate 3 years from now, 4.12%. Okay? So these are annual rates stated for a periodicity of 1. They are effective annual rates. The first rate, the 0y, 1y, is the 1 year spot rate, of course, because it's starting from time 0. The others are 1 year forward rates. Given these rates, the spot curve can be calculated as the geometric average of the forward rates. So here I put in the formula for the geometric average, which we learned back in the quants, which is big brackets 1 plus rate 1 times 1 plus rate 2, etc., times 1 plus Rn to the power of 1 to the n minus 1. Okay? So from that, we can calculate the 2 year implied spot rate by multiplying 1 plus 1.88% times 1 plus 2.77% to the power of 1 over n, so it's the power of 1/2. So we'll just bring up the calculator here, and we'll just do a quick review of the math. So that's going to be 1.0188 times 1.0277. Then we're going to do yx to the 0.5, and then we'll do our minus 1 and equals 0.02324, which we've got here. So the 2 year implied spot rate is 2.324%. Bringing up the calculator again to do the 3 year spot rate. Okay, I'll just clear the calculator. Just give me a second here. And it's going to be 1.0188 times 1.0277 times 1.0354, and then that's going to be y to the x, 0.3333 minus 1, and you can see we've got 0.027277, or rounding. Okay, so the 3 year implied spot rate is 2.72278%. Okay. Okay, we're going to do a quick practice question here, and I would say on the CFA continuum, this is one of the harder ones because there's just a little bit of a trick here, and until you've seen that trick the first time, it's easy to make a mistake. Anyhow, we'll go through it. Assume the following 6-month forward rates presented on an annualized bond equivalent basis were calculated from the yield curve. So we've got the notation 1F0, forward rate 0.5%, 1F1, 0.7%, 1F2, 1%, 1F3, 1.5%, 1F4, 2.2%, 1F5, 3%, and 1F6, 4%. So the 3-year spot rate is closest to A, 0.74%, B, 1.48%, or C, 2.06%. Okay, this is an excellent question. It's the type that fool me once, shame on you, fool me twice, shame on me, because there's two things that we need to do. First of all, when they give us the rates here, they're giving 6-month forward rates, but they're being presented on an annualized bond equivalent basis. So step 1, we need to take the rates and divide by 2, okay? Then step 2, we're going to do the geometric average, okay? Then step 3, we need to take that geometric average and then multiply it by 2 to get us to the right answer. So there's 3 steps here, step 1, step 2, step 3. Once you know them, it's not that difficult, but unless you've done this question once, you know, it's a little bit tricky. The other thing is they're asking for the 3-year spot rate. So you can see these are 6 months. So that's 1 year, that's 2 years, that's 3 years. So this rate here we don't need, okay? So as I said, step number 1, we need to take these rates and divide them by 2. And this is how I would do it on the exam as well. I'm going to just use the space provided to me beside the question to make some notes. Of course, you're not allowed any scrap paper, and don't write anything on the desk, okay? So of course, 0.5% divided by 2 is going to be 0.0025, okay? 0.7 divided by 2 is going to be 0.0035. 1% divided by 2 is going to be 0.005, okay? 1.5% divided by 2 is going to be 0.0075, and 2.2% is going to be 0.0110, and finally the 3% is going to be 0.015, okay? Now to do the geometric average, recall the formula is going to be 1 plus the rate times 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 1 plus the rate to 1 over n. And you can see our n here, 1, 2, 3, 4, 5, 6. N equals 6, okay? So if we just bring up the calculator again, and I guess I'll just move it over here to the left-hand side so we can see our numbers there a little bit. We're going to do 1.0025 times 1.0035 times 1.005, just one too many zeros, times 1.0075 times 1.011 times 1.015. We're going to do, then we have to do y to the x, 1 divided by 6, okay? So let's just write that down, 1.045377, 1.045377, okay? And just bring up the calculator again. 1 divided by 6 gives us, it's going to be to the power of 0.16666. 16666. Okay, so again, just bring up my calculator. 1.045377, y to the x, 0.16666. Then we're going to do minus 1. Okay, and remember, we need to multiply it by 2 as our last step. So I'm going to multiply that by 2. And if I want, I'm going to times it by 100 so I can get a nice round number. And I've got equals 1.48%. So the correct answer is B. Maybe that one, you know, when in doubt, guess B. In this case, you would have been right. So anyhow, a little bit of a tricky question, but not impossible. The math is not that difficult. It's a geometric average. But you had to know step 1, because there's 6-month forward rates presented on an annualized bond equivalent basis, you need to divide the rates by 2. Then you do the geometric average, but when you get your solution, you're going to multiply it by 2. Okay, good little question. Okay, where are we heading now? We're heading towards calculating forward rates from given spot rates. We're going to see the math in the next slide. This slide has got some theory. Just stick with us because there's some nomenclature here that's a little bit confusing, but once you work your way through the numerical example, it becomes a little bit more clear, okay? But anyhow, let's read through the theory here. The no arbitrage principle is quite simple. It says that tradable securities with identical cash flow payments must have the same price. Otherwise, traders would be able to generate risk-free arbitrage profits. Applying this argument to value a forward contract, we consider the discount factors, in particular the values P brackets T star and P brackets T star plus T needed to price a forward contract, okay? The forward contract is F brackets T star comma T. This forward contract price has to follow, which is known as the forward pricing model. P brackets T star plus T equals P brackets T star times F brackets T star comma T, okay? And as I said, don't worry about the algebraic nomenclature here too much. We're going to see it in a numerical example in the next slide. So, but to understand the reasoning, consider 2 alternative investments. Buying a 0 coupon bond that matures in T star plus T years at a cost of P T star plus T, and entering into a forward contract at F brackets T star comma T to buy at T star a 0 coupon bond with a maturity T at a cost today of P brackets T star times F brackets T star comma T. The payoff for the 2 investments at T star plus T are going to be the same, okay? So for this reason, the initial costs of the investment have to be the same, and therefore the equation must hold. Otherwise, any trader could sell the overvalued investment and buy the undervalued investment with the proceeds to generate risk-free profits with 0 net investment. So now we'll start to get into the numerical examples on this slide and the next, okay? And what we're doing is we're calculating forward rates from the spot rates. So continuing now with the maturity structure of interest rates, given spot rates for 1, 2, and 3 year 0 coupon bonds, how many forward rates can be calculated? So 3 forward rates can be calculated from the 1, 2, and 3 year spot rates. The rate on a 1-year loan that begins at the end of year 1 can be calculated using the 1 and 2 year spot rates and the following equation, okay? So I wrote here the end and the start. That's I wrote that just to help you a little bit because I want to show you it's 1 plus R2, that's the to the power of 2 equals 1 plus R1, so that's the start, you know, to the power of 1, and that's the end. So it's starting 1 year from now for 1 year, okay? Times 1 plus F brackets 1 comma 1 to the power of 1, all right? So again, the rate on a 1-year loan that starts at the end of year 2, so you can see here I put the end of year 2, and it's going to start at the end of year 2. It's going to end at the end of year 3 because it's a 1 year, okay? It's a forward, 1 year forward 2 years from now, okay? So 1 year forward 2 years from now. So you can see how I set up the equation. It's 1 plus R3 to the 3. That's at the end of 3 years, equals 1 plus R2 to 2. That's the start, brackets 1 plus F2 comma 1 to the power of 1. So additionally, the rate on a 2-year loan that begins at the end of year 1 can be computed from the 1 and 3 year spot rates in the following equation. So you can see here, I had to put in red because this is a 2-year loan that's beginning at the end of year 1. So again, starting at the end of year 1, it's going to end at the end of year 3 because it's a 2-year loan. So you have to memorize this formula. So this is probably throughout the CFA curriculum one of the harder sections to get on top of, but not too difficult, okay? If you work at it and practice and go through the examples a couple of times. But definitely you have to become familiar with these formulas, how we calculate the spot forward rates given the various spot rates. Okay, now it really helps to work through a numerical example. So we've got the spot rates for 3 hypothetical 0 coupon bond zeros with maturities of 1, 2, and 3 years. So we've got the maturity 1 year, 2 year, 3 year, and here's the spot rates, 9%, 10%, and 11%, okay? So those are zero coupon bonds with maturities of 1 year, 2 year, and 3 years, okay? So we're going to calculate the forward rate for a 1 year zero issued 1 year from today. So that's the forward 1 year, starting 1 year from now, ending 1 year after that. So remember, here's the formula. So as I said, we're going to do 1 plus R2 to the power of 2 equals 1 plus R1 to the power of 1, brackets 1 plus forward 1 year forward 1 year from now to the power of 1. So you can see this is the, on the left-hand side, that's R2, that's the rate for the zero coupon bond with a maturity of 2 years. So it's 1 plus 0.1 to the power of 2 equals 1 plus 0.09 to the power of 1 times 1 plus the forward 1 comma 1 to the power of 1. So here's what we're solving for. We're solving for the forward 1 year forward 1 year from now. So how do we do that? We're just going to do the algebra. We need to divide 1.1 to the power of 2 divided by 1.09 minus 1. It's as simple as that. Let's just bring up the calculator. So as I said, once you start to see how the math works and you practice a little bit, it's not that bad. 1.1 y to the x 2, okay, divided by 1.09, and don't forget to minus our 1. And if we want to multiply by 100, so we can get a nice round number, we can see that we've got 11.009, or here it's been rounded to 11.01%. So that would be the rate for a 1 year forward starting 1 year from now. So to calculate a forward rate for a 1 year zero issued 2 years from today, then remember, so I just showed you your left side, right side. We start on the left side with when the forward is going to end, and on the right side when we're going to start. So that was just a little bit of help, okay? So it's 1 plus R3 to the 3, which is 1.011 to the power of 3 equals 1.01 to the 2, brackets 1 plus the forward. It's a 1 year forward 2 years from now. Okay, it's a 1 year zero 2 years from now. So again, just going to bring up the calculator, and it's not too bad. It's going to be 1.11 y to the x 3, so 1.367631, 1.3676, 1.367631, I believe, divided by, I'm just going to bring up the calculator, 1.1 y to the x 2, 1.21. So just bring up the calculator. 1.367631 divided by 1.21 minus 1 times 100, and we've got 13.027. You can see it's been rounded here to 13.03%. So that would be the forward rate for 1 year zero issued 2 years from today. Okay. So again, you have to memorize these formulas, how to calculate forward rates given the spot rates. So carrying on with the maturity structure of interest rates. So we've got the same spot rates for 3 hypothetical zero coupon bonds with maturities of 1, 2, and 3 years. So the spot rates are for 1 year, 9%, 2 year, zero coupon, 10%, and a 3 year zero coupon, 11%. So those are the spot rates. Now we're going to calculate the forward rate for a 2 year zero issued 1 year from today. So again, on the left-hand side, I always put where it's going to end. So it's going to be a 2 year zero issued 1 year from today. It's going to end at the end of 3 years. Okay. When is it going to start? It's going to start in year 1. So this is how we set up the equation. 1 plus R3 to the power of 3 equals 1 plus R1 to the power of 1 times 1 plus the forward rate, a 2 year zero issued 1 year today. So I put there in red, in bold, just to see that it's the power of 2. So then we just fill in and we do the algebra. 1.011 cubed equals 1.09 to the power of 1 times 1 plus the forward, the 2 year zero 1 year from today squared. So let's just bring up the calculator. You can see the keystrokes actually for this are not going to be all that bad. On the left side, it's 1.11 1, 1. Y to the x, 3. Okay. Now we're going to divide by 1.09. Okay, so you can just see that the numerator is the 3 because it's the end, divided by when it's going to be beginning is the 9. Okay, but so it's to the power of 1/2. So we're going to do yx 0.5. Okay, because we have to solve for this, so we're going to put to the power of 1/2. Then it's going to be -1. And if we want to multiply by 100 to get a nice round number, we can see that we're at 12.01372, or 12.01%. Okay, so the upward sloping zero coupon yield curve is associated with an upward sloping forward curve, a series of increasing 1-year forward rates, because 13.03% is greater than 11.01%. Okay, so a little bit of math there. It just takes a little bit of practice to calculate forward rates from spot rates. So continue with the maturity structure of interest rates. We have thus far discussed the spot curve and the forward curve. Another curve important in practice is the government par curve. The par curve represents the yields to maturity on coupon-paying government bonds priced at par over a range of maturities. In practice, recently issued on-the-run bonds are typically used to create the par curve because new issues are typically priced at or close to par. Okay, so the par curve is important for valuation in that it can be used to construct a zero coupon yield curve. The process makes use of the fact that a coupon-paying bond can be viewed as a portfolio of zero coupon bonds. The zero coupon rates are determined by using the par yields and solving for the zero coupon rates one by one in order from earliest to the latest maturities via process of forward substitution known as bootstrapping. Again, this becomes more clear when you work through an example. Okay, so in this case, we're going to have a 1-year par rate equals 5%. Note that's the 1-year spot rate as well because we're starting from time 0 and it's a 1-year rate. The 2-year par rate is 5.97%. and the 3-year par rate is 6.91%. So from these, we can bootstrap the zero coupon rates, the spot rate. And you're going to see this is how we do the math down here. Okay, here's the formula. So the 1-year zero coupon rate is the same as the 1-year rate, par rate, because under the assumption of annual coupons, it is effectively a 1-year pure discount instrument. However, the 2-year bond and later maturity bonds have coupon payments before maturity and are distinct from zero coupon instruments. The process of deriving zero coupon rates begins with the 2-year maturity. The 2-year zero coupon rate is determined by solving the following equations in terms of one monetary unit of current market value using the information that R1 equals 5%, or R1 equals 5%. So here's our one monetary unit, and so we're going to, here's what we're solving for. We're solving for the 2-year spot rate, okay? So it's 0.0597. We're discounting that back by 1.05 plus 1.0597. That's the 2-year par rate divided by 1 plus R2 to the power of 2. Okay. That's the 2-year zero coupon rate. That's what we're going to solve for. So let's just go to the next slide and we'll work through the math. Okay, so we're going to solve through this math. 1 equals 0.0597 divided by 1.05 plus 1.0597 divided by 1 plus R2 to the power of 2, because we're going to calculate the 2-year spot rate, okay, by bootstrapping. So in this equation, 0.0597 and 1.0597 represent payments from interest and principal and interest, respectively, per 1 unit of principal value. The equation implies that R2 equals 6%, and we've bootstrapped the 2-year spot rate. But let's work through the math. I'm just going to bring up the calculator. So first of all, 1 equals 0.0597 divided by 1.05. So 0.0597 divided by 1.05. So we've got 0.056857, or rounded here to 0.86, equals 1.0597 divided by 1 plus R2 squared, okay? So we can see here, we're going to move the 0.05686 to the left-hand side. So we're going to make that a negative, and we're going to hit plus 1. Okay? So you can see on the left-hand side now, I've got 0.94314 equals 1.0597 divided by 1 plus R2 to the 2. So now what we're going to do is we're going to move the 1 plus R2 to the 2 to the left-hand side and multiply it by 0.94314 equals 1.0597. So 1 plus R2 to the squared is going to equal the 1.0597 divided by 0.94314. So let's just do that. 1.0597 divided by 0.94314, and we're going to get 1.123587. Okay, so 1 plus r squared squared equals 1.12359. So how do we get rid of the to the power of 2? We take the square root. Okay, so I'm going to take the square root, and we're going to subtract 1 because it's 1 plus. We're going to subtract 1, and we've got R2 equals 0.059994, which is being rounded to 6%. Okay, if I multiply that by 100 just to get our nice round number, 5.999939, so it's 6%. Okay, so the 1-year par rate 5%, 2-year par rate 5.97, 3-year par rate 6.94. We know that the 5% equals the 1-year par rate is the 1-year spot rate as well. Now the 2-year spot rate we have solved as 6%. So recall this LOS was to define forward rates and calculate spot rates from forward rates, which we did using geometric averages. Then the forward rates from spot rates, which we did using this formula here, 1 plus R2 squared equals 1 plus R1 to the 1 plus 1 plus F. That gives us the 1 year forward, 1 year from now. Okay, and remember this was forward rates from spot rates. So here are the spot rates, 5% and 6%. Okay, so recall, so this is nice because we're kind of carrying on with the numbers from the previous example where we were given the par rate, and given the par rates we used that to calculate the spot rates, the 5 and the 6 and the 7. So now that we've got the spot rates, we can move that ahead to calculate the forward rates given the spot rates. Okay, so as we know, the 1 year forward rate 0 years from now is the same as the spot rate. That's easy, but we need to calculate the 1 year forward 1 year from now, and we do that using this formula: 1 plus r squared, 1.06 squared equals 1.05 times 1 plus the forward 1 year forward 1 year from now. So again, just using the algebra, I can bring up the calculator here quite quickly. 1.06 y to the x2, okay, divided by 1.05, okay, minus 1. And if we want to multiply by 100, we can see that we've calculated the 1 year forward rate 1 year from now to be 7.009 or 7.01%. Okay, very nice. So you can see I did a little check here, and this is the whole point, what we're getting at in terms of the no arbitrage opportunity. If I have $100 and I have a 2-year spot rate of 6%, I can get $100 times 1.06 times 1.06. I'll have $112.36. But if I invest it for just 1 year at 5%, I'm going to have 100 times 1.05, and then buy a 1 year forward 1 year from now, not a 2-year spot rate, then the rate has to be 7.01% to get me the same $112.36. If that rate is different, then there's an arbitrage opportunity. Okay, so I think this is hopefully becoming more clear to you now. So we had the 1 year par rate of 5%, the 2-year par rate of 5.97%, and the 3-year par rate of 6.91%. So the 5% equals the spot rate. We calculated the 2-year spot rate, 6%. We calculated the 3-year spot rate by 7%. Okay, great. So now we're moving on to calculate the forward rates given the spot rates, which we've already done in the previous LOS, and we're using this formula here: 1 plus R2. That's the 1 year forward 1 year from now. So it's 1 plus R2 squared equals 1 plus R1 to the power of 1 times 1 plus the forward for one year forward 1 year from now. Okay. And so as I said here, if I invested at 6% for 2 years, $100 times 1.06 by 1.6, I'm going to have $112.36. That means the 1 year forward 1 year from now has to be 7.01%. Okay. Hopefully this is becoming a little bit more clear, but as I said, this is maybe one of the trickier areas of the CFA curriculum. Just takes a little bit of practice. Okay, we're almost there. We got 2 more slides left for this LOS. So again, the 1 year par rate was 5%, the 2 year par rate 5.97, the 3 year par rate 6.91. We used that par rate curve to calculate the spot rates, 5, 6, 7%, and then given the spot rates, we're calculating the forward rates. So the 1 year forward 0 years from now is 5%. The 1 year forward 1 year from now was 7.01%. So now we're going to calculate the 1 year forward 2 years from now. And we've seen this before. We've done the calculations. Here's the formula. So it's a 1 year forward 2 years from now. So remember I said on the left-hand side we're going to do the end. So it's 1 plus R3 to the 3, and that's the spot rate. That's the 7%. Equals, and this is where it's going to begin, so it's going to begin after 2 years for 1 year, 1 plus R2, and that's the spot rate, 1 plus R2 squared times 1 plus the forward rate, the 1 year forward 2 years from now. Okay, so it's not too difficult. It's going to be 1.07 to the power of 3 equals 1.06 squared times 1 plus the forward rate, 1 year forward 2 years from now. Okay, so just bring up the calculator here. And we're going to do 1.07, going to be y to the x3 in the numerator, 1.225043, 1.225043, okay, and we're going to divide that by 1.06 y to the x2, which is 1.1236, 1.1236, just check that. And so we're going to do 1.225043 divided by 1.1236. We're going to do minus 1 and times 100, so we get a nice round number. And we've got 9.028. Okay? So you can see that the 1 year forward 2 years from now is equal to 9.028%. And again, I like this little example here to check so it's no arbitrage. Let's say you had $100 and you had a 3 year spot rate of 7%. So you would have $100 times 1.07 times 1.07 times 1.07. At the end of the year, 3 years, you'd have $122.50. Now, if I invested it at the 2 year spot rate and then bought a 1 year forward 2 years from now, I would have $100 times 1.06 times 1.06. So it has to be 1.09028 to get me my same $122.50. Otherwise, I'd have an arbitrage opportunity. Okay, so 2 different routes. I could buy a maturity for 3 years at the spot rate of 7%. It's going to give me $122. Or I could buy $100 for a 2 year maturity at spot rate 6%, and then a 1 year forward 2 years from now, the rate would have to be 9.02% to get me to end up at the exact same place. Okay, no difference. Okay, so now we're going to show you how to calculate the price of a bond using the forward rates and using the spot rates, and we're going to finish this LOS with this slide. Now don't hate me, that's probably a bit of above and beyond the call of duty for this LOS. This example really is from my level 2 slides, tailored to level 1, but sometimes I think it's good to go above and beyond the call of duty. That's why I don't have too many practice questions at the end of this LOS. If you go into the text, and you'll see that actually there is no practice question where you need to calculate the price of the bond using the forward rates. Nevertheless, it is part of the LOS. It says calculate spot rates from forward rates from spot rates, and the price of a bond using forward rates. Okay, better safe than sorry. Anyhow, so we had the par rate 5%, 2 year par rate 5.97, 3 year par rate 6.91. We used that par rate to calculate the spot rates 5, 6, 7%. Then we know that the 1 year forward 0 years from now is the same, 5%. 1 year forward 1 year from now, 7.01. And we calculated the 1 year forward 2 years from now to be 9.028%. Okay? So now we're going to look at an example of a 3-year 4.25% annual coupon bond could be valued using the rates that we calculated. So first of all, using the spot rates, we'd have the coupon 4.25 discounted using the spot rate. We know we've looked at calculating the price of bond using spot rates before. This is nothing new to us. So for the second coupon divided by 1.06 using the spot rate to the power of 2 years. And then we get back our principal and our last coupon, 104.25, divided by 1.07 to the 3 years. So we've got 4.04. I'm not going to bring up my calculator for this. That's the present value of the coupon 1, present value of coupon 2, and that's the present value of the last coupon and getting my principal back. And we have a price of 92.92936. Now that we've got the forward rates, you can see what we're doing here. The numerator is the same. That's easy. But for the denominator, for year 1, it's the same, 1.05. But now what are we doing for the denominator? For year 2, it's the 1.05 times 1.0701, okay, which is the same as 1.06 squared, correct? And so now I think you're starting to get it. And so now our 104.25 for year 3, the last coupon plus the $100 par, we're going to divide it by 1.05 times 1.0701 times 1.09028, okay? And if you do the present value of those coupon payments plus the principal, you're going to get to the exact same price. Of course, you have to, otherwise there's an arbitrage opportunity. So on that, I think we've done a pretty good job at calculating spot rates from forward rates from spot rates, the spot rates from the par rates, and finally the price of a bond using those both the spot rate and the forward rates. And that's the last for this LOS. It's been a bit of a tough and tricky one, but I think if you go back and review the slides, you'll find that it all holds together. Thank you.